Hey everybody, I'm back here and we're going to sketch some graphs putting everything together that we talked about. We're going to do horizontal shifts, vertical shifts, and also reflections and vertical and horizontal compressions and stretches all at the same time. So the first thing I want to do is I want to make sure that my function is in a certain form. So I want to make sure that my a value comes first, then I have my function. In this case is a quadratic. So I would want to have like my b value times x minus, I'm going to put an h here instead of a c because there's going to be two c values. That would be squared plus a k. So this is the form that I really want it in, and this is my vertical stretch or compression. This is my horizontal stretch or compression. This is my horizontal stretching or shifting, and this is my vertical shifting. Okay, so these are all the things I want to be able to pick right out of the equation, and the way that this is written doesn't give me that information. It might be misleading. So I just want to rewrite this. So the first thing I'm going to do is I'm going to keep the negative 2 times x minus 1 squared plus 3. That's how I'm going to write it. So now we can see that my a value is negative 2. So not only am I stretching this thing vertically, I am also reflecting it in the x-axis. I have a shift of 1 to the right and a shift up of 3. Okay, so if I was going to write this function, if I wanted to say describe, if I said describe the transformations that are happening to the parent function x squared, I would say f of x is shifted 1 unit to the right three units up. It is vertically stretched by a factor of 2. And even if I was going to say, if I say compress, I could still, like, let's say this was 1/2. If I said compressed, I would still say by a factor of 2. You can say that. Or you can say it's vertically stretched by a factor of 1/2. But typically we want to use the compression when it's relevant. Okay? And then reflected in the x-axis. So sorry, my handwriting is terrible. So let's go ahead and now graph this thing that I just described. So here we have our graph. And because I described it first, it helps me sort of come up with the correct scale and everything. I know I'm shifted 3 up. So let me just rewrite the function. F of, oops. So f of x is negative 2 times x minus 1 squared plus 3. Did I get that right? It is, okay. So this is my x direction, my y direction, my scale is 1 in both directions. So what I know is normally x squared starts at 0, 0. This one is starting 1 to the right and 3 up. So that's right here. There's my vertex. Now from there, my horizontal movements are unchanged. So out 1 every time. Out 1, out 1, out 1. However, my vertical movements are going to be multiplied by negative 2. So instead of going up 1, up 3, up 5, up 7, I'm going to go down 2, down 6, down 10, down 14. Okay, so that is how the negative 2 is going to affect that. It not only changes the 1, 3, 5, 7 to 2, 6, 10, 14, it also changes up to down because of the negative. So normally I would go up 1, but I'm going to go down 2, out 1. The out 1 is not affected. It's going to continue to be out 1. Then down 6. 1, 2, 3, 4, 5, 6, out 1. Then down, normally it'd be down 5, it'd be up 5. I'm going to go down 10. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't fit. Okay, I might make it fit. So down 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 8, 9, 10. Here we go. Out 1. And so here is my graph. I'm doing the best I can. I apologize. That's terrible. But you have the points, and that's the important thing, that you can read off these points. And I didn't have to make a table of values. I didn't have to do any work. All I had to do was have knowledge about what each of these pieces does to my original function, and I have to know what my original function looks like. Okay? So we will come together in the next video to do this last example. I will see you in the next